So today's question is binary search tree to greater sum tree. So we are given the root of a binary search tree and then we have to convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys that are greater than the original key in BST. So we have to update the value of each node such that its value is equal to value plus sum. The sum should be such that all of the nodes are greater than the original key. So as a reminder, a binary search tree is a tree that satisfies these constraints. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. So we know according to binary search tree that if we have a root, the left node should always be less than root and right node should always be greater than root. This is the rule that BST follows. So now let's look at an example test case that was given to us. This is an example test case. And let's try to understand how we can use the BST concept over here. So according to BST, we know that all the roots that are right side of a node, all the nodes that are right side of a particular node are always greater. So this side, you can see in the following diagram, 6, 5, 7, 8. This side are always greater than 4. And this side are always less than 4. So what is the question asking us? We have to update the node's value such that this will be 4 plus sum of all of these. So what is the sum of these? 6 plus 5, 11, 11 plus 7, 18, 18 plus 8, 26. 26 plus this value, that is this value should have 30. And similarly for this also, we have to go to the right and try to add all of them and get it. For this also, you have to add all of them. So what are we doing every time? We are moving towards the right downwards. So to do this, we can do DFS. So what is the condition? We have to keep going right until we arrive at a condition wherein there is no further node. So that will become our base condition here. So if root is equal to null, then we return. Otherwise, what do? We keep going towards the right. So we call the function root.right. And before that, we have to initialize our sum value is equal to 0 because each time we update the sum and the root dot value. So what is the question telling us? The root dot value is equal to root dot value plus sum. Okay, so let's check it. We go right. Again we go right. Again we go right. It's not null. Here we go right. Now this is null. When this is null, we return over here. So our return comes here and here. So now what is root dot value? Root dot value is equal to root dot value plus sum. So what is the value of this node? This node will become 8 because sum is 0. Now we have to update our sum. Our sum will be equal to root dot value. Okay. And then again we go back. Now what is here? Here the root dot value is 7. So this root's value will be updated as 7 plus what is the sum? Sum is 8. So this will become 15. Now what is sum? Sum is this root's value, that is 15. Now again we go here. What is root dot value? 6. What is sum? 15. This will become 21. Now again when we come here, we have two choices. We can go left or right. So here we can go left also. Because for this is less, this is greater. So when we go here, what is the value of this? This is root dot value is 5. 5 plus what is the sum? 21 until here. So 5 plus 21 is 26. And then again we come back and we go here. Now it is 26 plus 4. So 30. So this is how this works. And let's try and code this. So what's our first step? First we have to call the DFS. DFS root. And what are we supposed to return? We are supposed to return the tree with whatever modifications we make. So we'll return the root. Now let's call the function public void. We are choosing void because we are not returning anything. Rather, we are making changes to the original tree itself. So tree node root. Now what's the base condition? If root equal null, return. Otherwise, what are we doing? If it's not equal to null, we move towards the right. DFS root dot right. Each time we have to update the root's value. We're updating the root's value with sum. So we'll initialize the sum with 0. And then the sum is updated to root dot val. Once we finish the right part, we go to the left part. Let's run and check it. Yes. Now let's submit it. And yes, this is submitted. And this is how you can solve this problem. Yes. And now let's submit